Hey guys, welcome to Shinobi Codes, and today we are here for lecture number 3 and we'll be mastering recursions over here. And today our main focus will be finding the factorial of n. Okay, so before getting into how to solve this problem, I just want you guys to know what a factorial is. So factorial is usually represented using this sign or this sign. So n factorial or this, and n factorial is actually product of all numbers from 1 to n. Okay, so you can always write this, and I've also written some stuff already so that it takes less time. So n factorial is product of all numbers from 1 to n. So let's just here I have calculated 5 factorial. It's product of 1 2 3 4 and 5. Eventually it is 120. Now carrying on this pattern, I want 4 factorial. It will be 1 into 2 into 3 into 4. Okay. Now there's one very interesting fact, that if you observe that 4 factorial thing, this entire thing is here in 5 factorial also. Yeah, this thing is common. So I can write 5 factorial as product of 4 factorial and 5. And we can also generalize this for any n. We can say that n factorial is always equal to n minus 1 factorial into n. So this we have generalized this thing. Now I want to solve this using recursion. So first of all, how will I get this intuition that I have to solve this using recursion is after seeing this thing, because this is a recurrence relation. A recurrence relation is a proof. Like whenever I have already told you that if you can divide a problem into sub problem, in that case, or if you can find a recurrence relationship, or function calling function kind of stuff, then you always have to use recursions. So here I have found this recurrence relation. And what is the recurrence relation? I can always write f of n is equals to n into f of n minus 1. This is the recurrence relation. Okay, so let's just code this recurrence relation quickly. So I am opening the Sublime text and deleting everything. Yeah, so okay, so let's just first form a int main, and in int main there is an integer n, and we are inputting this integer n. Okay, and also calling a function. We are also calling a function which will return integer, so I am outing directly the value. So we want the factorial of this function, so I am outing this thing. So int factorial will take a argument n, and what it will do is, I can always say that the answer of this problem will be equal to factorial of n minus 1 into n. Yeah, this is your answer, and we just have to return this answer. Now as always, we have to find a base case. Now there are two interesting facts about factorial which I want to discuss before proceeding further, which are very important to understand the base case. The first property is just a significance of factorial, which is that if you are given like n distinct boxes of different colors, and you have to arrange them. Okay, so 1 2 3 and 4. So if you have to arrange these 4 distinct objects, like total number of permutations possible, then its answer is 4 factorial. Now deriving from this property, we somehow I don't want to get into technicalities, but you can see the video, any video on YouTube, that 0 factorial is also 1. Okay, using this definition. So this is fact number 2. So I want to make this function fact of fact of n to give me an output for every possible value of n. Every possible value includes only positive and 0. Okay, because negative factorial doesn't exist. So I have to make some cases. Okay, so first I have to assure that the factorial of n, which the function is the int factorial of n, I have to assure that n has to be greater than 0, because if n is greater than 0, then only we can continue, or else we can return we have to return an integer. Let's return an integer -1. in the case if the the n value is not greater than 0. Now the second case, the second base case, I can always write. Now I'm using this indentation, so from here I can always write if n is equal to 0, then this base case will give me, I have to return the value 1, because I have already understood that 0 factorial is 1 by definition of factorial. So if n is equal to 0, I have to return a value of 1. One base case is enough in this problem, which you can see intuitively. So then I have to just write the recursive relationship. So I guess these two cases are enough to, I think these two things are enough to handle all the cases. So first I just have to assure that n is greater than 0. If n is greater than 0, then only proceed in the function ahead, okay, and it will get inside of this only if n is greater than 0, or we can say equal to also. And if it is not entered, it has not entered into this entire thing, then we can always return the value of -1. Okay, means obviously, and we can put a if condition over here. If answer is equal to -1, then please see out that no factorial is possible. Now always if n is equal to 0, we always have to return the value of 1, and then I think rest is enough. Rest is enough, I guess. So let's take the value of 3. Okay, and let's just run this code. Okay, wait. So yeah, no, answer is 6. Okay, let's just take another example. Let's take example of 5. Wait, yeah. So in case of 5, it is returning 120. So this is, I just want to do a quick dry run on this program. So let's do a dry run. I have pasted the code over here, and let's just analyze that how is this giving me the right answer for every possible value of n. So first I called factorial of n from the main, and here it will get into this function, and I will call factorial of 5. Now factorial of 5 will check if it is greater than 0. Yes, it is greater than 0, so it will get inside of this, and then n is not 0. So we want the answer. For answer, first find factorial of n minus 1. So this will first call factorial of 4. Now similarly, factorial of 4 will be called, and again it will call factorial of 3. Then this will call factorial of 2. Then this will call factorial of 1. And this will finally call factorial of 0. Now we have to assure this thing that factorial of 0 will return when factorial of 0 will be called, then n equal to 0 condition will be enough, and it will return a value of 1. Now here this pointer will come exactly here. Okay, so here the value will be 1, and it will multiply it with its n, and n is equal to 1 for factorial of 1. So we get the answer of 1, and it will again return a value of 1. It will multiply this 1 with 2, and I will get 2, so it will return a value of 2. We will multiply 2 with 3. The program will multiply it with 3 and return a value of 6. Now 6 will multiply this with 4 and will get a value of 24, and it will return this value here. Now 24 will be multiplied with 5, and I will get 120, and it will return this value here, and it will eventually see out this value 120. And this is a quick dry run. Okay, so that's it for today, guys. Please like, share and subscribe this video.